Assalamualaikum, apa khabar semua? Jumpa lagi kita. Saya harap anda semua selesai mendengar part pertama. Okey, kita akan sambung hari ini part ketiga, part keempat topik kedua, which is physical organisation of parallel platform. InsyaAllah saya cuba habiskan chapter 2 hari ini pada video ini. Dan kita akan move pada chapter 3 insyaAllah minggu hadapan. So PRAM consists of P number of processor and a global memory of unbounded sizes that is uniformly accessible to all processors. So all processors access the same address space, which is the memory itself. Processors share a common clock but may execute different instructions in each cycle. This ideal model is also referred to as PRAM. Since PRAM allows concurrent access to various memory locations, depending on how simultaneous memory access are handled. So there are four subclasses of PRAMs. So the classes is divided based on how memory access are handled, how the processor might or can access the memory. So different classes might have a different way of accessing the memory. So the first class is exclusive read and exclusive write, or EREW PRAM. Second classes is concurrent read, exclusive write, PRAM. Third classes is exclusive read and concurrent write PRAM. And last classes is concurrent read and concurrent write. So read and write, what is read and write? Read and write memory itself. So the first class, in this class, access to a memory location is exclusive. No concurrent read or write operation are allowed. Exclusive means when let's say we have three processors in this PRAM. Let's say that we have a machine, PRAM machine. In this machine, there are three processors. So when we say it is exclusive read and exclusive write, there is no concurrent read and no concurrent write between these three processors. So let's say P1 is reading the memory. So P2 and P3 can't read the memory at the same time. So this is the weakest PRAM model, affording minimum concurrency in memory access. There's no concurrency in memory access. The second class is concurrent read and exclusive write. What is exclusive write? Write means you are writing or editing, or you are saving something to a memory. So in second class of PRAM, it's allow a processor to do a concurrent read. What does it mean with concurrent read? So we go back to our first example. Let's say we have a PRAM machines with three processors. So let's say we have P1, P2, and P3. So P1 and P2 can read a memory at the same time or concurrently. However, in this class, the writing process, the editing process, or accessing to write or to edit memory and space can only be done exclusively. Means if P1 writes the memory, P2 have to wait. So in this class, multiple read access to a memory location are allowed. However, multiple write access to a memory location are serialized. Serialized means they need to do it one by one. The third class is exclusive read and concurrent write. It is a vice versa from the second class. It's vice versa from the second class. And the last PRAM class is concurrent read and concurrent write. It's allow multiple read and write access to a common memory location, and this is the most powerful PRAM model. So we know that this is the ideal PRAM model in this class. Okay, previously in the previous slide we have mentioned that the most ideal PRAM machines is the fourth class, which PRAM machine that allow a concurrent read and concurrent write. So allowing concurrent read access does not create any semantic discrepancy in the programs. The word semantic discrepancy might might seem jargon for you. Semantic discrepancy here, you want to say that even though we allow a processor to do a concurrent read to the program, to the instructions, tak ada beza dari segi how you the syntax of the program. So itu untuk concurrent read. However, concurrent write access to a memory location requires arbitration. You have to find how to pronounce it correctly. Sorry for my pronunciation. So apa maksud kat sini? Kalau kita concurrent read, tak ada masalah masing-masing nak read, but concurrent read, we do it simultaneously. We don't need to have to make a queue ataupun nak write a different program. We can use a similar program. However, in writing a program, in allowing a concurrent write to a memory, let's say we have a variable named A. Okay, it stores a value, a parameter value. Dari parameter A, kita letak dekat memory. Processor 1, processor 2. You want to do a concurrent write in for A in the memory, variable A tadi. So in this situation, the program needs to specify which task need to write first and which task need to do second. Kadang-kadang mungkin P1, let's say at first A equals to 2. The value of A is 2. And then processor 1 wants to do a task, okay, that needs that use A as the output. So they want to edit A. Okay. And then A is required as input in processor 3. Okay. And then A required by processor 3 is A equals to 2. P2 wants to write a similar variable A, but it wants to edit A, it will become 10 after this. So the program need to specify which processor can do the write to the variable A. Mana satu processor yang boleh ubah variable A? P1 dulu ke P2 dulu? So in this situation we know P1 dulu kena ubah, and then we have to allow P3 to read the A, the variable A, then baru we can proceed with P3. So that's why kata kalau nak write, concurrent write, access to memory location requires arbitration. Arbitration here means kalau awak cari definitions, dia kata mesti ada satu persetujuan lah, kind of agreement between two disputing. Kena ada agreement antara P1, P2 and P3. So several protocols are used to resolve concurrent writes. So ada beberapa protokol lah yang kita boleh gunakan untuk do the concurrent write to resolve the mentioned issue before. So the most frequently used protocol as follows. Antara protokol yang ada ialah first protocol is common, in which the concurrent write is allowed if all the values that the processors are attempting to write are identical. Jadi boleh tulis ini arbitrary, in which an arbitrary processor is allowed to proceed with the write operation and the rest fail. Arbitrary ni maknanya in this protocol dia allow mana satu yang dapat agreement, yang dapat izin, dia akan boleh proceed. Yang lain tunggu dululah. Okay, dalam kes kita tadi kita kena bagi P1 dululah to write, and then P3 to read, baru kita boleh bagi P2 to write. Priority, in which all processors are organized into predefined prioritized lists, and the processor with the highest priority succeeds and the rest fails. So ini based on the priority, the protocol allows a processor with highest priority to do the write process. And last sekali is protocol called sum, in which the sum of all the quantities is written. The sum-based write conflict resolution model can be extended to any associative operator defined under quantities being written. Okay. For the second part, we are going to look into the physical organization of parallel platforms is interconnections. We know that I have mentioned a couple of times before. There are two types of parallel platform. First is multiprocessor, which is communicate through a shared address space. Second is multi-computer, where it will communicate through message passing. So how they will pass a message pass the message through the interconnection network to the network. So in this chapter, in this part, we are going to look at what type of network, how it will connected. So interconnection networks carry data between processors and to memory. So interconnects are made of switches and link. Usually switches is switches, and link will be a network link. It will be wires or fiber. Interconnects are classified as static or dynamic interconnections. So static networks consist of point-to-point communication links among processing nodes and are also referred to a direct network. Second type of network or interconnection network is dynamic network, usually using switches and communication link. Dynamic networks are also referred to as indirect network. Usually static networks, we are going to connect one PC to another PC directly. Whilst dynamic network, we are going to use switches where we can add and remove the PC that connects to the network anytime. These are examples of a static versus dynamic network. So these are the difference between static and versus dynamic. On the left hand is a static dynamic. If we will look into it, P represents a processor or a computer, and the straight line here is the network, the link that are connect between one PC to another PC. So so it might have a network interface that in each processor might have a network interface. While the dynamic network, all the processing element will connect to the switching element. So, what is network topologies? Network topologies is how the design or how network will be connected. There are a variety of network topologies that have been proposed and implemented. So each of the topologies has their own trade-off performance for cost. Commercial machines often implement hybrids or multiple topologies for reason of packaging, cost, and available components. So you are going to look into the several types of network topologies. However, practically, usually people will use the combination of those topologies, not stick to the single type of network topologies only. So the first type of network topology is a bus network. So it's the simplest and the earliest parallel machine use buses. So all processors access a common bus for exchanging data. Bus represent, this is what we call as a bus. Okay. However, the bandwidth of the shared bus is a major bottleneck. Typically, bus-based machines are limited to dozens of nodes. For example, it has been used by Sun Enterprise servers and Intel Pentium-based shared bus multiprocessor are example of such architecture. So if we look at the diagram here, so there are, let's say here there are two PCs and there is a shared memories. So the bus network here, the link, what we call it as bus, because the link between one PC to another PC. So processor 0, if you want to share a memory, you want to go to shared memory, you need go to processor 1 and then will be the shared memory. So that's why the bandwidth of the network here will be shared by processor 0 and processor 1. Bandwidth 1, we know that bandwidth is how many data can be carried in one time. So that's the limitation of path network. The second type of network topologies that we are going to look is a crossbar network. Crossbar network uses P times M grid of switches to connect P inputs to M outputs in a non-blocking manner. What does it mean? There is a P and there is a, let's say we have a processor and memory banks here, and each of these is interconnected through the switching element. So kat sini ada switching element. So what happened? The cost of crossbar of P processors grows as P to the power of 2. So banyak processing element, cost dia akan jadi P to the power of 2 lah. Untuk apa? To make them connected. To make all the processors connected, the cost might the incur is P to the power of 2. This is generally difficult to scale for large values of P. So example of machines that employ crossbar include Sun Ultra HPC 10,000 and the Fujitsu VPP 500. And then the enhancement of the crossbar is multi-stage network. So crossbar have excellent performance, scalability but poor cost scalability. So apa maksud scalability? Bila kita nak tambah tu, kita boleh tambah bila-bila je. Okay, apa maksud dia? If you allocate back at the crossbar design, kalau nak tambah P element, nak tambah new processor, you just need to add some switches. However, in terms of cost lah, tambah P maknanya tambah switch lah. Okay. So multi-stage interconnect strike a compromise between this extreme. So apa yang berlaku? So instead of kita buat pakai switch, kita guna stage. So stage here represent the switches. So each stage has their own switches. Okay, so these are the multi-stage network. So another part is multi-stage omega network. Ini extra, you may refer to textbook 2.4.3 for more details. And this is omega network, this is an example. And then there is a completely connected network. And then star connected network. So the rest of this topic I'll talk about type of networks or topologies that consist. You may read by your own. Okay, class. That's all for topic 2. This is the cost, which is passing cost in parallel computing. So you may read by your own. It's clear. Okay. So thank you. I love chapter 2.